Hello and welcome to another session of Hive. So in this session, we'll talk about joins in Hive. Now, similar to your relational database, Hive also supports all types of joins. You can have your inner joins, the outer joins, left outer join, right outer joins on the tables. Apart from that, there are a few other joins that Hive will support. But let's try some joins that how you will try in your normal relational database. So I'm at the MySQL database. Here I have certain tables. Now we already created the order tables at the Hive. So let me just go ahead and check this table. So I will limit it to 10. So we have some data in the order table. Now there's another table which is order items. So we have other table called as order items. So I'm not sure if we have created the table, but let me check this. We have not yet created this table. So let's do something. Let's create this order items table, and then we will query the order items table and order ID orders tables using joins. So if I describe this, I have order ID, order date, order customer ID, and order status. This is for orders. And if I do an order items, I have order item ID, order item, order ID, product ID, quantity, subtotal, product price, right? So I have order ID here, and the same order ID we have it here. So that will be used for a joint purpose. Okay, so let's go ahead and create this Hive table. So we will create an external table. I'll give the schema here, and I have to copy all this, so let me quickly do this. This will be int. We have our product ID, which will be again int. Then we have item quantity. We have item total, subtotal, which is float, and in Hive it will be double, and item price is again float, so we will take it as double. So these are the columns that we have, and of course you have to give the format. It's row format delimited, and your fields are terminated by comma. So we are going to use the data. We are going to basically use the file that is already present in the Hive location. It's in the Hadoop location. Remember, all the 6 tables we have copied to the H location. From there moved it in, or we copied it to the HDFS location. So we will use that because we have created an extended, we are creating an extended table, so we'll use that location. So back to the topic, our fields are terminated by comma, and lines are terminated by slash n, which is new line. This is stored as a text file. All these are text file, and the location is it's user Cloudera I data sets, I believe data sets, and I think it's order items. But let me quickly check that. Let me verify that it should be order items, but it's better to verify this once. Yeah, it is order items. So all right, so let me go ahead and execute this. All right, so we have the table created. So I'll quickly check this data. Let me limit it to 10. Okay, so I have this data. So what I will do is I am going to, let me also query the data on orders and have it ready here, so you can see that on screen. All right, so what I'm going to do is I'm going to select some of the column data. So let me pick up from O is my orders table. So, and if I go back here, what do I have in orders? So I have order ID, I have order status and order date. So I'll pick up order ID from here, and I will also pick up order status. And that's the two columns I need. And then OD is basically my order details. So I will pick up just one column. Let me pick up what do I pick up? Let me pick up the order item product price. Okay, this should be good. So yeah, I just need few columns. I just wanted to try the join condition, that's all. So this is from orders O. Let me try inner join. So order items OD on. So this would be order ID, which is on order, and this would be order items order ID. All right. Okay, so let me execute this. So this failed, and the reason for it failure is we need to set up some property for join, right? By default it is going to be true, so we have to set it for false. So let's say hive dot auto convert dot join is equal to false. We have to set this false. By default it is true. So what is the meaning of this, what it does mean? So when it is true, and when the table size is less than 25 MB, the joins are auto converted into map based joins, and we will see what map joins are, what map based joins are in a little while. But this is what it means. If it is true, it is basically saying that if you find something which is 25 MB or less, it is going to convert that join to map based join. So we are not executing a map based join here, we are executing a normal query. So we'll have to convert this to false and then go back and execute this query again. Now this is executing, and you should see the results in a while. We have this data here, and for this we have mappers as well as reducers invoked. So there is a data shuffling that is happening. We can also put a left outer join, right outer join, all these joins will work. Apart from these joins, we also have few more joins. So are the joins that Hive supports apart from your normal SQL joins. So one is map join, second is bucket map join, then we have sort bucket map join and skew join. Now bucket map join, sort merge join and skew join is something which is not commonly used. It's very rare use, and again you have to set up a lot of properties to use this. But one thing which is commonly used is the map join. So how map joins work is, let's understand this with an example. So let's say you have two tables. This is table 1 and this is table 2. Let's call this table, maybe we can give it employee, and let's call this table as department, right? Now if you have to join these two tables, what map based join means is the table which is smaller, let's say this is a smaller table, right? Department table is always smaller. Now what will happen is, when you're doing a join, the data from this table, department table data, will go and sit on the data node of employee table. So this is one time shuffle that happens. Now join will happen here, and then the data will get released, right? So suppose if the employee table is in let's say the employee table is here, it is in data node 2, 1 and 2 and 3. So we have the employee data in 3 data nodes. All right, so this is the employee data. let's say you have here we have the employee data in three nodes, and let's say this is your department table. Now during the map join or map join, what will happen is this data will basically get shuffled, and it will go and sit in each of this data node, and then the join will happen here, the join will happen here, the join will happen here. When you have a join, the join is happening on the same data node, so within the same data nodes join is happening here, right? So this way we can reduce the this way what happens is we can basically reduce the time it takes. Otherwise, if it is into separate nodes, every record there has to be a shuffle just to make sure there is a comparison here and there, so that avoiding that, and this will improve the performance of the join condition. Again, it is only advised if you are having a small table. If you don't have a small table, then it doesn't make any sense to have all those big tables go and sit on the other data nodes, right? So if you want to execute the map phase join, we just have to make one small change to our query. So this is, let's look at the query that we have. So this is the normal query that we have executed. Now what we have to do here is we just have to give the hint and say, you know what, this is map set join. So I have to say you have to give plus, and you have to say map join smaller table, and I have to close this. That's it. So if I execute this, it will execute as a map join, and and it will give out the result. You may not see significant changes here because both the tables are small, but then if you execute this query on a bigger tables, one is a bigger table, the other is a small table, you will definitely see a lot of changes. The earlier query executed in 29 seconds, and this time using a map phase join we got this result in 23 seconds. There is a slight improvement, but even there will be a lot more improvement every time if one of your tables is really large, but still we can see some performance improvement when you use a map side join. So this is something which is very commonly used. Now the other type of joins are something which are not very commonly used, so I'm not gonna spend too much time on this because there are a lot of properties that needs to be set up, and something which is not really that common. But anyway, I'm going to walk through what these are. So the first thing that we want to talk is bucket map join. So for bucket map join to take place, we have to set two conditions. First thing is both the join tables must be bucketed. So if you have two tables, table 1 and table 2, both of them should be bucketed. Again, we talked about what bucket is. We create the bucket, we basically divide the data which is in ranges into different ranges, small buckets, kind of small part files. And the reason why we do is if you query on a particular column on a range of which is having a range of data on a regular basis, then it's a good idea to bucket that, so that your query will not go and scan the entire files, but will just scan the required buckets. So that's the first condition that we should have. Both your tables should have buckets, and the second condition is it should be bucketed on the join key. So if you have table 1 and table 2 and your join key is, let's say, id, you both of your tables should be bucketed on the id column. And the other thing is the number of buckets between two tables must be multiple of each other. So if, for example, if table 1 has 2 buckets, then table 2 must have buckets in multiples of 2. So that is, it could be the 2, 4, 6, 8, those many buckets, right? So these are the certain conditions that we need to have for the bucket map join to take place. and of course we have to set up two properties. We have to enforce bucketing, and we have to set Hive optimized bucket map join equal to true. So when you have those two properties set, and then you have these criteria that I mentioned, then you can go for, then it will be called as a bucket map join, right? So this is a query here. Table 2 is basically the smaller table. There's no change from the previous query, but then the only change is the properties that we set. And both these tables, if they are having buckets, if they are bucketed and bucketed on the same ID, and if they are in multiples of each other, then the query or the map join that happens is called as a bucket map join. That's the only difference, guys. There's nothing difference in terms of how we use the queries, but you know preconditions, the bucketings and other things that I mentioned, those needs to satisfy for it to be called as a bucket map join, right? So this is how it works, the bucket map join. So let's say you have two tables. Table 1, let's say it has 8 buckets. Table 2 has 4 buckets, right? So what will happen is the similar buckets will go to the same mapper. So if you see here, for table 2, again buckets are based on modulus, so you will have 1, and then the for bucket 2 you may have 1 and 5 buckets where the modulus is same. So this data, the records which are in bucket 1 in table 2 and bucket 1 and bucket 5, so they will go into the same mapper, so they will do the join from there. So this way we are basically joining the corresponding buckets, instead of one bucket going and joining with all the other buckets, right? So this is how the bucket map is join happens. So the join happens within the buckets, and these buckets will have the similar data, so you will have the same kind of IDs, and you can basically join in within the buckets. This is another illustration how the bucket happens. So if you see bucket 0, it only just goes and does the map side or does a join on bucket 0 and bucket 4, because basically these are the same buckets which have the same modulus, right? And similarly bucket 1 will go for bucket 1, and it will go for bucket 5. So this is how the bucket map join happens. The join happens within the buckets, right? So the next join is the sort merge buckets join, and this is very similar to the bucket join what we have seen. Now in what is the difference is there's only one difference. In bucket map join, data is not sorted. So before you join, the data is not sorted, and if you want to sort the data before join, which is a good practice in general. So if you want to if you want to first sort the data and then do the join, then you use a sort merge bucket join. That's the only difference between the sort merge bucket join and the bucket merge join, or the bucket map join. And of course there are some additional properties we need to set. So these are the 4 properties that we need to set in order to make sure that we have a sort merge bucket map join. All right, the next is the skew join. Before understanding skew join, we need to understand what is data skew. So data skew is primarily refers to the non-uniform distribution of data. So this basically means that some values appear more than others. For example, let's say we have this table, we have the department number 10, 20, 30, and we have the count, like 10 is appearing 3 times, 20 is appearing 7,800 times, and 30 is appearing 300. Now if you look at the department number 20, the number of occurrence of 20 is predominant here. It's more than, it's a large than the other two values. So we say that the data is skewed here because this is not uniform here. 7,800 is way bigger than 3 or 300. So let's imagine a situation where we have two tables, employee and department, and department number 10 we have 1 million records, 20 has 20, 30 has 12, while in the department table we have department number 10, 20 and 30, and the counts are like almost it's very minimum 10, 1 and 1. Now if you do a join a department number on the employee and department, so what will happen is here we will run into a situation where a single reducer or a few reducer will process the 1 million records. Now the other reducers will just process the 20 or 12 or 1 records, and they will run faster. They will complete their execution faster, but your job will be on hold because the reducer which is processing the 1 million records is going to take a lot of time. So there is uneven distribution of work for the reducers. So in such scenarios, what we do is we can use a skew join. Now how does this work? So what happens in skew join is basically you are joining the on skew column. Now the table that has the less skew, so here in this example we have the department table which has less value. Now the table that has the less skew, which is department table, now this department number will be stored in memory for that particular data only. So in your map join you store the entire data, but here what is happening is you just join the data, a portion of, you just join the portion of the data, like here the department number 10 is skewed, so we just store this department number 10 data in memory for that particular skew data, and it is only for this particular skew data. So this particular record will be stored in memory, and when the join happens, this memory will go and sit here, and the join will happen between this data which is skewed and this particular data. This means that the map side join occurs, but it is only occurring for a particular skew data. So it is only occurring for the skew data 1 million records. Other things are happening. All other data will follow the normal map reduce. So this is how a skew join works. So you just take the data which is skewed and then you bring it to the memory, and then the map side join happens only for that skewed data. The rest of the data, it basically follows the normal map reduce jobs. And there are certain properties that we have to set. So these are certain properties that we have to set for this skew join to take place. And again, as I mentioned, skew join, a sort merge join, or the bucket join, bucket map join is something which is not very commonly used. Map side join is something which is commonly used. We have seen an example. You can try with the other joins as well, but you need to make sure that you set the right properties, and then you should have the data right, the bucketing, the number of buckets which are in multiples of each other. So you have to make sure that you have all this data set up before you can try the other joins, the bucket map joins or the sort match joins or even the skew joins, right? So that's it for this session, and thank you so much for listening, and I'll see you guys in my next class.